Welcome. Today we're going to be looking at the Bernoulli principle, and we're also going to talk about how shapes and fluids interact with each other. So first thing I want you to think about is, how does this shape affect its movement through the fluid? In this particular case, my question is, does it? Yes or no? What do you think? So we're still looking at the same I can statement, but this time we're looking at Bernoulli's principle and what we call drag. You've probably heard that word before, and some everyday examples of the Bernoulli's principle. We're going to cover the review question number 7. So try this out. What I'd like you to do is tell me which you think is going to move faster through a fluid. Which of these two pieces weighs more? Which will fall faster? Oh, in other words, there is this idea that shape affects the movement through a fluid. Why is that? This has to do with the surface area. The flat sheet of paper has more surface area than the crumpled piece of paper. So more surface area equals more drag. And the Lab 47408 is a video that you can go in and watch. There is no lab report, but go in and watch that video and see how the surface area can influence the drag. So we know that shape affects how things move through a fluid, which is an air or a liquid. But what is drag? Think back. We have a force that we can use to help us describe what drag is. It's friction. So frictional resistance of an object that is moving through a fluid has its own term called drag. It slows it down, but it's still a friction. Let's review what is pressure. What do you remember? Tell me all the things that you can remember. Here are some examples of ideas that we could apply pressure to. So we have, how are we using pressure in this case, or in the case with the bulldozer, or in the case with the scuba diver? What do we know? So we have this example of a small area being used to increase the pressure, the knife's edge. Like a needle of the syringe, that's also a small area that is used to increase the pressure. The tip of a shovel, high heels, those are all examples of using a small edge to increase the pressure. In this case, our bulldozer, they have these increase the wheels here, or the track, to reduce pressure, like skis, for example, tractor tires, snowshoes, the caterpillar tracks. Those are examples of large areas that are trying to reduce the pressure. And then we have in here, as we go down in depth, we increase the pressure. So this person here needs some equipment to help them as they adjust to a different area. All right, so Bernoulli's principle says if you increase the velocity of the fluid's flow, you decrease the pressure. So what is velocity? Check out, make sure you know that one. We haven't talked about it in a little bit. And here are some examples of applying Bernoulli's principle. If we use the idea of aerodynamics, we can slice through fluids easier. Another example is the shape of our airplane wings. We increase or decrease the shape. So when we see these airplane wings being, they have some rudder type capabilities, and that will change the pressure around the wing. So when the speed of the fluid increases, the pressure drops. We can use that with example with the hose. Think about what happens when the water gets bunched up. Here's some picture examples of explaining Bernoulli's principle. And what do you think? According to Bernoulli's principle, what happens when velocity of the fluid flow increases? If you're not sure, go back in and check the recording, the previous slides, to help you out. Explain how the wing achieves lift. Here's an example of this. And another example of moving something in. There's some fun experiments that you can do. I am going to share that video out with you. But these are things that you can do in your house also. For example, take a piece of paper and blow gently over the top of it. What's going to happen? How about here? You have two balloons sitting next to each other. What happens if I grab a straw and blow some air between them? Well, what will happen is they will draw towards each other. All right, so we've now reviewed some of the ideas of Bernoulli's principle, really cool, fun principle. Please be sure that you're understanding the material. Take that practice quiz to test out your understanding. Review the material if you don't get 80% or higher, and take it again so that you are sure you have that knowledge. Be sure to check any of your quizzes, tests, missing assignments, late assignments. Get those all above 70% or better. And code word for today is on the board. If you have any questions, please just let me know so that I can help you out, and have a great day.